Okay, guys. So let's move for topic 1.4, that is the embedded system software. So we already discussed about embedded system hardware. Now we'll be talking about software. So you have to talk about four things about the software components. So first is nothing but the initialization code. Okay, so before we move to the components, let us just read a definition for the software. An embedded system requires software to function effectively. The software is structured in multiple layers, each providing a higher level of abstraction from the hardware. Like multiple layer of level of abstraction. So like higher the layer, higher the level of abstraction. It's like that. Software components are initialization code. In initialization, like the first code executed on the board. It set up the minimum hardware requirement before the OS take control. So initialization code is nothing but the initialize meaning itself is like to start something, right? So basically, if you're starting, then obviously it's the first code, and then it sets up the hardware requirement. So based on the code, whatever the hardware requirement is there, it sets up the minimum hardware requirement. So and then it gives the control to the OS. Sometimes what happen if you don't set up the requirement, then it will uses complete all the hardware. It's just exhausting the system, nothing else. So this is good for the system, like for the software. Then operating system, what it does, it manages the hardware resources and the applicant execution. I mean, in the sense, whatever the resources are there in the hardware and execution of the application. Then device drivers, very simple, provides a consistent interface for peripherals. In the sense, it provides the interface for input and output operations. Applications, it performs specific tasks like mobile phone, diary, applications like all your mobile apps or whatever you have to use. Different game is also application, calculator, etc. etc. Software components can be stored in ROM, firmware or RAM. First, we'll talk about 1.4.1 initialization. You don't have to worry, it's not much. You have 1.4.1, 1.4.2, and 1.4.3. Initialization, boot code, operating system, and application. Under initialization boot code, you have to remember initialization code is nothing but from state. It changes the OS from two states, from the rest or sleeping state to an functional or operational state. Understood? See, the boot code transitions the processor from reset state. Sorry, I told about the rest. It's not rest. It's reset state to an operational state, preparing it for the OS or scheduler. Basically OS, but sometimes there is also scheduler in that. This process involves three key phases. What process? From transitions from reset to operational state. First, you have to do initial hardware configuration. It configures memory controller, processor, cache, and some devices. Memory remapping may be necessary to place RAM at addresses 0x, there are 8 times, okay, to store the exception vector table. Usually, if you look into the textbook, let me just go a little up. See, you don't see any specific, what to say, point over here. So here it's not necessary to mention the points, but you can mention these points and like, or else mix up the points and write that. So that shouldn't be a problem. Then diagnostic tests the hardware system for, see, usually these points are the only, see, whatever these points are there, right? This ignore the heading, but the points which you are seeing are actually the points. But we cannot simply write points. Yeah, we're just enhancing our points by giving it a heading or title, so that like classifying them, separating, grouping, like that. It's okay. In diagnosing, we test the hardware system for faults before the software executes. So before we are performing software execution, we will just test the hardware for any faults are there or not. So you'll be see, we are talking more about hardware and software together. Usually it happens, right? For example, digital meters for vehicle, it's a hardware thing but has a software thing. See, a mobile phone is also having a hardware components but also have the software components. Basically most you see the screen software, right? The laptop, it has a screen of software but it has components hardware, so they have to work together. It's all about that. So before the software executing something, the hardware should be checked for any faults, and then if there are any faults, that those faults should be isolated, and it helps in manufacturing. That's the second point. Booting, it loads and executes an image for the of the OS on an application, like restarting or refreshing, launching, like that. You have that remote, right? Like rocket symbol. If you tap, it will free up the RAM, like that. And it can involve copying data into RAM or directly executing from ROM. You can imagine or understand this with the example of your own phone. Just think all these things or relate all these things to your mobile. You'll be able to understand more easily. Some system compress the boot image to save space and decompress it during the execution. Like in the sense, initially it will be compressed to save space. For example, zip files and stuff. But when you need to extract it, it just decompresses, like that. Then we have to talk about operating system. There's no much to talk about operating system. As you can see in the textbook, they itself has just given this one small paragraph, but here we'll be talking about two types of operating system. Before you go move ahead, we'll just see the definition or the explanation. The operating system organizes the system resources like peripherals, memory, and processing time. The ARM processor supports over a 50 operating system, and in the sense 50 plus. So they have categorized into two types: real-time operating system and platform operating system. So real-time is nothing but like when event trigger type, like they will perform at the specific time itself, like airbags in a car, or you know see pacemaker. It will be like very strict type of thing. Real time operating system, it guarantees the response times to event, like, so for every event it gives a guarantee that it would respond on time for that particular event. It is used in systems without secondary storage, so we don't need any secondary storage over here. It has two types of real-time operating system: hard and soft. Hard are nothing but strict response type, and soft are nothing but like they are like delays are tolerable, like video streaming for your YouTube live, Instagram live stuff, and not TikTok live and all. You understand? Hard is very strict, soft is like simple, like that. Then you have platform operating system. It requires a memory management unit, and it uses a secondary storage as well, and it is non-real. So you just have to write opposite of this. What it has here, without secondary, so there is a secondary storage. Memory management is required over here, and here you can see also what is that. Uh, Real time, it is non-real time. Simple, over. See, we have moved to the application part. Application, nothing but application of the embedded systems. You just have to talk about networking, automotive, mobile, mass storage, imaging, etc. Then key takeaways, you can just read. It's just a small glance for that. Then we'll just be talking about chapter 1 is concluded over here. You can see in the syllabus you have chapter 1 topics. So all these topics have been concluded. We'll just see a small recap of that. First, we'll be talking about embedded system introduction. What embedded system has, like why it is designed. It is optimized for what. Then ARM embedded system, low power consumption, high performance, good code density. Then follows a modified risk. Then examples you had, right? Features of that risk, you saw that multiple things like thumb. We also had two more things which are not shown here, but they come at the top of the thing, like 4 or 6 were there in that. Only 4 are being displayed over here. And then embedded system hardware, see memory hierarchy, cache, main storage, then secondary storage, memory types, ROM, flash ROM, DRAM, SRAM, and SDRAM. Peripherals and controllers. Peripherals are nothing but provides input out functions, memory and interrupt. Interrupt has again two types, right? One is standard and another is vector. Then embedded system software, which we just saw now, initialization boot code or initialization or boot code. Operating system, two types: real time platform. Real time has again two types: hard and soft. Applications of it. Then the summary concludes the chapter, and then in the next topic we have to talk about ARM processor fundamentals. If you see in the syllabus, I will happily tick the topics which I have completed. This was completed, this was completed. Now this was completed in the previous video. This we have now. Now we have to talk about ARM process fundamentals, which will be talking about registers, current program status registers, pipeline. It's very interesting from here. We'll just start this in the next video. Okay, bye bye, see you.